All right, let's continue on and talk a little bit more about atoms and review just real briefly how we find, yes. I want to be sure you can see. All right, so let's look at these periodic table entries that you have where we left off. And we'll just get a little bit of practice sort of understanding what's shown in your periodic table entry. So, Ali,
Yeah.
since it's your birthday, I have another gift for you. I'm going to allow you to answer the first set of questions. So, Ali, this is potassium. This is a periodic table entry. Given this periodic table entry, you can now give me all of this information about potassium. So, Ali, what is the symbol of potassium?
Okay.
Correct. What is the name of potassium?
Potassium.
Wow, very good.
How'd you get that? You probably froze the screen.
No, I didn't.
Did you though? Maybe
All right. How about its atomic number, Ali?
Hold on. Wait, 19.
19. How about its atomic mass, Ali?
39.1.
Correct. I rounded it there. How many protons, Ali?
19.
How did you know this?
Because it says it. The atomic number is the number of protons.
Correct. How about the number of neutrons, Ali?
About 20.
Okay. Not about, because you can't have a part of a neutron, so it's a whole number. Yes, 20. And finally, electrons, Ali.
19.
Excellent. Very good job on your birthday. All right. Next up, aluminum. Drew, let's go with aluminum here. So symbol, Drew, of aluminum.
AL.
AL. Name, Drew, of aluminum.
Aluminum.
Atomic number.
13.
Atomic mass.
27.
Number of protons.
13.
Neutrons.
Got it from here? 14.
And electrons.
13.
Excellent. How about bromine?
Nice.
College. Symbol.
BR.
Name.
The name is bromine and it's bromine.
Correct. Atomic number.
Atomic number is 35.
Atomic mass.
79.9, I rounded to 80.
Yes. Number of protons.
35.
Neutrons.
45.
Electrons.
35.
Excellent. Any questions about how we do this? Simple, right? Too easy. All right. What? Somewhat. It's going to be more drawing atoms. So we have a couple of different ways that we draw models of atoms. Okay? And so we're going to show you, I'm going to show you these two ways, and then your homework is some practice doing this. So one method of drawing the atom is the orbital method. And so it's pretty simple. It's just sort of a visual model of what the atom sort of looks like. So we calculate the number of protons, electrons, neutrons. We draw a circle depicting the nucleus. We write in how many protons and neutrons are in the nucleus. And then we draw a circle for each electron shell. And we draw little dots in there to illustrate how many electrons are at each energy level. So we start with aluminum. We have our circle, which represents the what? Nucleus. What's in that nucleus of an aluminum atom? Raise your hand if you can tell me. Ella? Can you be more specific? Correct. 14 neutrons and 13 protons make up the nucleus of a single aluminum atom. How many electron orbitals are present? How many shells we might call them? Sienna?
13.
Well, there's 13 electrons, but they're not all together. What tells us about where these electrons are actually located? Zainab? Yeah, these bottom three numbers tell us where these electrons might be located. So we draw a circle to represent each electron shell. So here's the first shell, the one closest to the nucleus. And there's only 2 electrons in that shell. In fact, this first shell only can hold 2. It's pretty small. It's located close to the nucleus, so it doesn't have a large sort of radius. How many electrons in the next shell? 8. You draw another shell with 8 in it. These should be about equally spread out. And then finally, in aluminum, how many electrons in the outermost shell?
3.
3. So that is a model of an aluminum atom. We call this the orbital. So could you do the same for fluorine?
Yeah.
Or yes? How many protons in fluorine? 9. How many neutrons? 10. How many electrons in the first shell?
2.
And the second shell? 7. So the other way we sometimes do this is rather than draw the actual circles, we can write in numbers there, just showing that there are various amounts of electrons in the shell. And magnesium? How many protons?
12.
Electrons?
12.
Neutrons?
12.
2.
Good job, Max.
282. Got it? Simple? Too easy?
No. Very hard. Difficult. No.
It needs more practice. Yeah, we need to.
All right, that's your homework score. More practice.
We need no.
I think.
So, are these atoms drawn to scale?
Absolutely.
No.
Because if they were drawn to scale, how big would our paper have to be? Enormous, like the size of a
Football field.
football stadium. Not a field, a stadium. Because most of the atom is, almost all of the mass is found in the nucleus.
And it's incredibly dense.
All right, now we have another method of drawing a model of an atom called electron dot diagrams. These are actually a little bit more useful. You don't have to speak, that's okay, just look. And so the electron dot diagrams of an atom actually only show the valence electrons. What are valence electrons? Remind me. Have we defined them yet? We did it?
Some GPU.
What are the most important electrons in an atom that dictate how it interacts with other atoms? Ella? Which electrons? The what?
I'm not lying.
Well, the outermost level. And that's what we call valence electrons. The electrons in the outermost level of an atom are called valence electrons. And if you notice in your periodic table, everything in group 1, how many electrons in the outer shell? Potassium, sodium, rubidium, they all have 1 in their outermost shell. How about in group 2? They have 2 in their outer shell. Look all the way over to group 13. They all have 3. Group 14 has 4, 5, 6, 7, 8, so forth. So, yes, to see it. Yeah, it's because of their they're sort of in between those different groups where you have some of them have 2, some have 1. They sort of don't follow the same pattern, but they all have less than 4. All right, so if we want to draw an electron dot diagram, what we do is we first, again, we write the symbol now of the atom we're interested in. And then we start to put dots representing only the valence electrons. So how many valence electrons does aluminum have? No. Look at the periodic table. Valence electrons. Outermost electrons, how many?
3.
3. So we draw a dot on the top, and another one on the side, another one on the bottom. We start on top and work our way clockwise. Well, now how will we do fluorine? Write the symbol. How many valence electrons?
7.
7. we gonna put the next one? On top. Magnesium. Simple, 1, 2. So, when we are making these electron dot diagrams, we're only concerned with the valence electrons. So here's the order we follow. Top, right. See how that works? Top, right, left, that bottom, left, top, right, bottom, left. If you look around your periodic table, do we ever have to go above 8?
No.
Not for valence electrons. Yes, question.
Why do these not have it?
Those are what are called man-made elements. They only, I thought you were talking about like these here. Oh, you were talking the ones with no electron dot? Okay. Yeah, so those are man-made elements. Most of those things that have, some of them have no atomic mass, or it's in parentheses, they have no electron configurations. Those are elements that were created in a particle accelerator. You know what a particle accelerator is? Oh, yeah, we're talking about. So they send atoms flying around this gigantic ring and smash them into each other. And they will temporarily sometimes form a brand new element that never existed before. However, it is typically very unstable and may only last less than a second. But scientists have tools to actually measure that. So those are man-made elements that don't really exist in nature. All right, so electron dots, look at sodium. How many electrons in the outermost shell?
1.
So simple, 1 dot on top. How about chlorine? We already did. How many total valence electrons?
8.
Nope, not 8, 7. 1, 2, 3, 4, 5, 6, 7. Do you get the point? Anyone confused? Do I need to go through all 8 examples, or can I skip them?
Skip them.
All right.
A video.
Should I do this now?
Yeah.
Play it.
And then go for the shop. Play it.
Actually,
No.
let me ask you something. So,
What is the wing?
I guess I won't do it right now. I'm not going to go into why certain elements form compounds. But if we look at this, look at sodium and chlorine. Do sodium and chlorine ever form a compound?
Yes.
You know what it's called? Sodium chloride. You know anything about it? So let me tell you this. So, yeah, I'm gonna do this. I don't want to talk about it. So it's gonna be super bad. All right. So we know what is a compound.
It's a mixture of 2 or more.
Yeah, 2 elements chemically bonded together to form a single molecule compound. Okay. So you could think of atoms as teenagers, sort of. Not going to quite say 7 fingers, but maybe. So all atoms would like to find a partner that could make them stable. What makes an atom stable? Having a full outer shell of electrons. Okay. So, for most elements, a full outer shell is what number? 8 outer electrons. Okay. And that makes the atom stable. Now, most atoms on your periodic table do not have 8 electrons in the outermost shell. Look at, are there any that do have 8?
Yeah.
Like what?
They're all in the 8, like group 18.
Group 18, like what?
Neon.
Neon,
Radon.
krypton, radon.
Xenon.
Now, if they have 8 in their outer shell, are they stable?
Yes. Most of the time.
Yeah, they are. And guess what? They're happy alone. They're okay with that. They don't need some other atom to make them happy. They're perfectly content to be on their own. So, what do you think they form compounds with?
Independent atoms themselves.
Nope.
They don't.
Things with
They don't, Ali. Good. They don't form any compounds. So, all of those elements on the far right, 18, group 18, helium, neon, argon, they're called noble gases. They don't form compounds. They are non-reactive because they have no need. They're happy alone. Well, the other atoms throughout the periodic table are not happy on their own. Okay? They want to get a full outer shell, and they could do that in a couple ways. Look at, for example, lithium. Now let's look at sodium. What's its electron configuration? 2, 8, 1. How could it get a full outer shell?
If it has, what's it called? If it becomes a compound with another atom that has 7.
Okay, how many electrons does it want?
7.
It could gain 7 and fill it up that outer level to 8. What would be even easier?
3.
Because then it'd have 4, it wouldn't be stable. What would be easier than gaining 7 electrons?
Giving away.
Get rid of that outer one, and then how many would it have in its next level?
8.
That's going to be happy. What about chlorine? How many electrons in chlorine's valence level? 7. What do you think chlorine would like to do?
Just get one.
Gain 1. What do you think is a match made in heaven? Sodium and chlorine? Because what does sodium want to do? Sodium wants to get rid of 1. Chlorine wants to gain 1. So they do that little exchange and then they stay happily together. Sodium as an element is a dangerous super reactive metal. In fact, if you have pure sodium, you need to keep it in a jar of oil. Under the oil, because if it's exposed to oxygen or water, it reacts violently and will explode. Chlorine is a gas, a dangerous, deadly gas. It's one of the ingredients in mustard gas used
Oh yeah. World War I.
in World War I. Dangerous, destroys lungs, kills you if you breathe it. Chlorine gas, extremely dangerous. So if we take this explosive reactive metal, combine it with this dangerous toxic gas, what do we get?
Something stable.
Sodium chloride, which you sprinkle on your food all the time.
That's what it says. It's salt. When you're over here, it's salt.
Yes, and we get just basic table salt. So the properties of a compound can be completely different from the properties of the 2 elements that make them up. Because it exists in nature as a compound. There are salt deposits.
Oh, it
okay,
does it.
where you have just sodium chloride.
Is it-
Because sodium and chlorine in nature don't stay on their own. They will form compounds because they're so reactive. So you don't generally find pure sodium or pure chlorine in nature. You have to isolate it and extract it. All right, so we'll talk more tomorrow about how compounds are made.
Can we watch the video?
Tomorrow?
Can we get our homework?
Yeah, you can get your homework now. Happy birthday to Ali.
Wow.
The gift of chemistry.
Wait, Ollie,
Such
how
a
old are you?
beautiful gift. It's a gift that won't stop giving.
Ollie, how old are you?
You're gonna do it.
are you going to forget all of us now? Well, they're too cool.